Hello guys, welcome to the fourth section of the course using AWS Compute. We will start off this section by creating a key pair. We would then securely access private instances. We'll then create machine images and security groups. Towards the end of this section, we'll create a load balancer. Now we move on to the first video of this section that deals with creating a key pair. A key pair is used to access instances via SSH. This is the quickest and easiest way to access your instances. Before we begin, ensure that you have your AWS CLI tool configured correctly. First, create the key pair and save it to disk. Then, change the permissions on the created file. This call requests a new private key from EC2. The response is then passed using a JMS path query, and the private key is saved to a new key file with the .pem extension. Finally, we change the permissions on the key file so that it cannot be read by other users. This is required before SSH will allow you to use it. Let's move on to launching an instance. There will be scenarios when you need quick access to an instance. Creating it via the AWS CLI is the quickest and most consistent way to create one-off instances. For launching an instance, you must have an existing key pair. We are launching an instance of AWS Linux using an AMI ID in the US East 1 region. If you are working in a different region, you will need to update your image ID parameter. Run this AWS CLI command using your own key pair name. When you can create an instance via the AWS Web Console, it involves many distracting options. When developing and testing, the CLI tool is the best way to provision instances. While the key name argument is optional, you will not be able to connect to your instance unless you have pre-configured some other way of logging in. As no VPC or security groups are specified, the instance will be launched in our account's default VPC and security group. The default security group allows access from anywhere on all ports and so is not suitable for long-lived instances. You can modify an instance's security group after it is launched without stopping it. If you have created your own AMI, then you can change the image ID argument to quickly launch your specific AMI. You may also want to take note of the instance ID value in the response from the API, as you may need it for future commands. We now take a look at attaching storage. Ideally, you will have defined all your storage requirements up front as code using a service such as CloudFormation. However, sometimes that is not possible due to application restrictions or changing requirements. You can easily add additional storage to your instances while they are running by attaching a new volume. For this part, you will need a running instance's ID. It will start with I, followed by alphanumeric characters. The AZ instance is running in. This looks like the region name with a letter after it, for example, US East 1A. I am using an AWS Linux instance. If you were using a different operating system, the steps to mount the volume will be different. And note that we'll be running an instance in the AZ US East 1A. Create a volume with this command. Take note of the returned volume ID in the response. It will start with VOL followed by alphanumeric characters. Attach the volume to the instance using the volume ID noted in the instance ID you started with. This is the command. Here's the volume ID and the instance ID. Now mount the volume device on the instance itself. We started by creating a volume. Volumes are created from snapshots. If you do not specify a snapshot ID, it uses a blank snapshot and you get a blank volume. While volumes are hosted redundantly, they are only hosted in a single AZ, so must be provisioned in the same AZ the instance is running in. The create volume command returns a response that includes the newly created volume's volume ID. We then use this ID in the next step. Next, we attach a volume to the instance. When attaching to an instance, you must specify the name of the device that it will be presented to the operating system as. Unfortunately, this does not guarantee what the device will appear as. In the case of AWS Linux, dev-SDF becomes dev-x VDF. So that's all for now.